In this video, we'll discuss physical properties of aldehydes and ketones. Due to the presence of this carbonyl group, aldehydes and ketones have their characteristic variations of boiling points and solubilities in water. So in this video, we will discuss how do they specifically affect how the presence of this carbonyl group is affecting these physical properties. So we are talking about two different physical properties here, the boiling points and solubilities in water. Now we know that this carbonyl group contains this carbon atom and oxygen atom, and due to the presence of lone pairs of electrons on the oxygen atom, there is a high electronegativity on oxygen atom. As a result, there's a strong dipole created in between this carbon and oxygen atom, making a partial negative charge on the oxygen atom and a partially positive charge on the carbon atom. Now, when there are carbonyl groups or multiple molecules, maybe aldehyde molecules or ketone molecules are close together, a dipole-dipole interaction can occur between this partially negative charge oxygen atom and a partially positive charge on the carbon atom of a different molecule. We call these interactions as dipole-dipole interactions. And remember, these interactions occur in between two molecules. So these type of interactions are known as intermolecular interactions. Now these intermolecular interactions are affecting the boiling points. Now we will see how the boiling points are affected. Now if we consider both aldehydes and ketones, aldehydes and ketones that contains 3 to 10 carbon atoms are generally liquid. But very simple aldehydes like methanol and ethanol are gases at room temperature. That means their boiling points are very low. Having a higher boiling point means they are liquid at room temperature. So as you see here, when the number of carbon atoms increase, their boiling points are increasing. Now, if we compare the boiling points of aldehydes and ketones with alkanes or ethers, now alkanes and ethers do not have these dipoles. Therefore, they don't have these interactions, intermolecular interactions. As a result, their boiling points are very low. But when it takes for aldehydes and ketones, they do have higher boiling points because of that presence of the carbonyl group, which leads to the dipole-dipole interaction. That's an important point. And these aldehydes and ketones have a lower boiling points than alcohols. Remember, the alcohols had the hydroxyl group, right? For example, 1-propanol here is an alcohol. It has an hydroxyl group. And if you recall the boiling points of alcohols, they make hydrogen bonds, which is a very strong intermolecular interaction than these dipole-dipole interactions. So alcohols always have higher boiling points due to the presence of this hydroxyl group. But aldehydes and ketones don't have that much of a higher boiling point, so their boiling points are lower than alcohols because they can't form these hydrogen bonds. Now, when we consider the aldehydes and ketones boiling points, those boiling points are increasing as the number of carbon atoms increases. What is the reason? As the number of carbon atoms increases, the carbon chain becomes longer, right? A longer carbon chain means there are more electrons to make the dispersion forces. Okay, So this dispersion force, as the dispersion forces increases, their boiling points are also increases. These dispersion forces are another type of intermolecular interaction. Now, these are the three points that I have highlighted. You have to take down to determine the boiling point differences from one molecule to another molecule. And as you see here in this diagram or in this table, you can do a quick comparison. The boiling point of a butane is 0 degrees of Celsius, but when it comes for propanol and propanone, they do have higher boiling points. And alcohols have a very high, this one propanol, which has similar mass, has a very high boiling point because of the hydroxyl group. So just by looking at the functional group, you should be able to deduce what type of boiling point these molecules can have. You should be able to do a quick comparison just by looking at the functional group. We'll discuss that in the questions. Now, the next physical property is the solubility of aldehydes and ketones in water. Now, what is determine this water solubility? When it comes for water solubility, something that quickly comes into our mind is any molecule need to make some type of bond with water molecules to make it soluble in water. Now, when it takes aldehydes and ketones, aldehydes and ketones can make hydrogen bonds. The good news for them. So, the oxygen atom in the carbonyl group can make hydrogen bonds with the hydrogen atom in water molecules. Okay, so each aldehyde group or carbonyl group can make 2 hydrogen bonds. Remember, each carbonyl group can make 2 hydrogen bonds. Okay. Likewise, ketones also can make these can make 2 hydrogen bonds with 2 water molecules. So due to this reason, they are water soluble, but not all aldehydes and ketones. Especially when the molecule is small, like 1 to 4 carbons containing aldehydes and ketones are soluble in water because they can easily form these hydrogen bonds. But as the number of carbon atoms are increased, what happens? This molecule becomes more bulky. So the water molecules can't reach the molecule aldehyde or ketone to form many hydrogen bonds. As a result, as the number of carbon atoms are increased, their water solubility also decrease. Okay. Now, in this table, you can see the facts that I just mentioned. Now, first, if you look at the boiling point variation, so for aldehydes, there are 3 aldehydes, methanol, ethanol, and propanol in the first 3 rows. You can see the boiling points are increasing as the number of carbon atoms are increased. Okay, because they can make more dispersion forces as the number of carbon atoms are increased in the chain. Okay, and if you take ketones also show the same trend. If you take propanone, butanone, 2-pentanone, there are 3 ketones that you can see: propanone, butanone, 2-pentanone, and hexanones. You can see their boiling points are also increasing as the number of carbon atoms are increased. Okay. At the same time, if you look at the water solubility, now small molecules, methanol, ethanol, and propanol are water soluble, and propanone and butanol, they are all water soluble because they can make hydrogen bonds at this number of carbon atoms. But as the number of carbon atoms are increased, they become slightly soluble with pentanol and 2-pentanone, 5 carbon containing aldehydes and ketones. and becomes insoluble for 6 carbon atoms containing aldehyde and ketone, because they can't make hydrogen bonds properly due to the presence of these um, long carbon chains. Okay, now let's see, check some example questions. Okay, the first question is, which compound in each of the following pairs would have the higher boiling point? Now we have two structures in part A. One is an alkane, and the other one is aldehyde. Okay. Obviously, the one with carbonyl group has to have the higher boiling point. So, ethanol has the higher boiling point. So, this polar carbonyl group can make dipole-dipole interactions in between two ethanol molecules, but alkanes do not make such strong dipole-dipole interactions because no carbonyl groups. Answer is ethanol. Propanol and pentanol. So this is the 3 carbon containing aldehyde and this one is 5 carbon containing aldehyde. So which one has the higher boiling point? Pentanol has the higher boiling point because pentanol contains a longer carbon chain. Okay, longer carbon chain will make more dispersion forces, right? More dispersion forces in between molecules. As a result, it's hard to separate molecules. Um, so it will have higher boiling point than propanol. Now C, butanol or 1-butanol. Now this is an aldehyde with COH and this is an alcohol, right, with hydroxyl group. Obviously, butanol, 1-butanol will have the higher boiling point because this can make hydrogen bonds and aldehydes will make dipole-dipole interactions. Dipole-dipole interactions. When it comes for the strength of the bond, these hydrogen bonds are much, much stronger than dipole interactions. Therefore, 1-butanol will have the higher boiling point. Now, question 2. Which compound in each of the following pairs would be more soluble in water? Solubility is all about making hydrogen bonds with water. Okay, so which one can make hydrogen bonds? So both the molecules can make hydrogen bonds because both of them have carbonyl group. But if we look at the amount of bonds can make, so this molecule can make more hydrogen bonds because there are 2 carbonyl groups, right? Remember, I mentioned each carbonyl group can make 2 hydrogen bonds with 2 water molecules. So this will make more hydrogen bonds. Okay. Okay. Part B, propanol and pentanol. Which one will be more soluble in water? Now, in this case, propanol has 3 carbons and pentanol has 5 carbons. Both are aldehydes. The trend is that when the number of carbon atoms are increased, the solubility decreases, right? Therefore, propanol will more soluble. So, because the less number of carbon atoms. And C, acetone or 2-pentanone. Both are ketones. Acetone has only 2 carbon atoms and pentanone, 2-pentanone has 5 carbon atoms. Always the shorter carbon chain containing compound will be more soluble in water. So therefore, acetone will be more soluble in water. Okay, that's all for the physical properties.